Yeah, so today we are dealing with the Miller Index, right? We are dealing with the Miller Index. We basically want to understand how do we draw the planes, and if we're given the planes, how will you be able to determine the Miller Index, right? And so you should understand the difference between planes and vectors. The vectors, actually giving you a directions, whereas planes, they are just surfaces. A direction refers to a vector that describes how you move from one point to another inside the crystal lattice from what we call the origin, which which is the frame of reference, and that origin is basically taken as zero. Okay. So the direction is usually in square brackets. Okay, meaning what does this mean? It means you are moving. Remember, h is the x, is along the x, and then k is along the h is k is along the y, and then l is along the z axis. So basically, it's the movement along the x, y, and z axis in the in integer steps. It can be one, it can be whatever. Okay. Example, you can have the direction 110. Okay, so if it's in the square brackets, it means it's a direction. Okay, and then if you are having this square bracket 110, it means a movement along this one. Remember, it represents x. Okay, this one it represents x. This one it represents x. So this is x, this is y, and then this is z. So it means you are shifting one unit along the x. Then the second one, it means you are shifting one unit along the y from what? From zero as the frame of reference. And then zero, it means 0 unit along the z-axis. It means you're not shifting basically. Okay. But now, how do you determine this direction? You choose the starting point, usually zero as the frame of reference. Zero, it will be the frame of reference. It will be frame of reference. Now, what you're basically doing is you're going to be moving h units along either x, k, and or y. Okay. You are moving h units along the x or k units along the y, and I units along the z. That is basically what I've mentioned here. If you are h unit along the x-axis, it means it's this one, or k unit, it means it's this one, or I unit, it means it's this zero. So but the most important rule is directions do not, this is the most key thing, do not necessarily pass through the origin. Okay, but yeah, this is basically the fundamental rule of these vectors. So if you are given the parentheses or the square brackets, not parentheses but square brackets, you know that you are dealing with what you call the directions or the vectors. But planes, on the other hand, they you will be given what you call the parentheses. Okay, that is the most important part. You'll be given this parenthesis. Okay, now it describes how plane intersect. Remember, the vectors, they tell us about how are you shifting from the movement from the zero frame of reference. But now the planes, they basically tell us about they basically tell us about let me, sorry about that, let me lower this one. Okay, sorry about that. Yeah. um Basically, the planes is how are you intersecting the x or the y or the z axis. Okay, so example, for example, if you are having 110, it means you are intersecting the x-axis at 1, and then or you are intersecting the y-axis at 1, and then you are basically not intersecting the z-axis, does not intersect. Okay, so I'll show you when you will be determining the Miller index that when something doesn't intersect, you are writing the infinity. It means it will never meet that axis. Now, how do you determine this? You find the intercept where the plane crosses the x, y, and z axis. Then you take the reciprocals of these intercepts, and then you clear the fractions because we want the whole numbers. And then you draw the plane by connecting the intercept points. And then you'd have the planes. But the important rule about these planes is planes must pass through the lattice points. They must pass through the lattice point. Remember, the lattice points, the points which represent the actual atoms, the molecules within the crystal lattice. Okay, within the crystal lattice. So basically that is the plane. But obviously with practice you'll understand this better. What we basically talking about. Okay, so that is the difference. The square brackets is the movement, and then the parenthesis is the planes. Okay, and then how is it found? Steps along the axis, and then reciprocals of these intercepts. And then for example 110, okay, it means you are moving 1 unit along the x-axis, 1 unit along the y, and 1 unit basically there's no any movement. Now, the other thing that you must know is if now you are given these directions, the planes with directions, okay, how would you know? If you are given the planes with directions, how will you be able to draw these planes, and how from these, will you be able to determine the Miller index? The square brackets indicates the directions like I've mentioned, and then the parentheses indicate the plane. So the given square brackets means the vector moves 1 unit along the x-axis, 1 unit along the y-axis, and 1 unit along the z-axis. Okay. Now, how are we gonna be able to draw these given these plane directions? Okay, you set up the coordinate system with 3 mutually perpendicular axes. What you basically do is, for example, you can do this. You can do this. I'm not good at drawing, but something like that. This will be your origin, then this will be your x-axis, this will be your y, this will be your z. Okay. Aha. Now, set up the coordinate system with 3 mutually perpendicular axes, x, y, z. Okay. Mark starting point at the origin. This is the origin. Okay. Now move 1 unit in the x direction, 1 unit in the y direction, and 1 unit in the z direction. It means if this is 0, it means you can even label this the ring. Okay. And this is 1 here, this is 1 there, and this is 1 there. It means that direction from here to there, and from here to there, and from here to there, they must be nearly equal. Okay. Basically, that's if you're given this direction or plane directions, that's how you'll be able to draw this. Okay. And then that's why now you are able to draw an arrow. You'll be able to draw an arrow from the origin to the point 1 1 1 1. This is your direction. Okay. This is your direction, so you can now say, okay, can now say in the y to show that now this thing is in the y direction. It moved from the origin. Remember, and the direction it tells us about the movement. So we have moved 1 unit from 0 from the origin. Okay, that's why we're showing the arrow, because the arrow it tells us about the direction. I hope it makes sense. So you must be able to, if you're given the planes, you must also be able to draw these things. Now you can also be able to find the plane, okay, to determine the Miller indexes or the Miller indices basically. Okay, when you're determining the Miller index, but I'll go into details. You first the plane, you have got 1111 intercepts. Okay, you have got this intercept. It means your plane, your imaginary plane. If you were to close your eyes, you can see your imaginary plane within that crystal. Okay, then now it is intercepting the x-axis at 1, y-axis at 1, the z-axis at 1 as well. Okay, then you're going to take the reciprocals of these things. So basically what you do is you are taking remember now you have got the intercepts, you've got your intercepts. So you've got your, okay, these are your intercepts. Now step number 2, and you have to show us you're taking the reciprocal. Okay, you have to show us. Okay, that's the Miller indices. It will just be 1 1 1. Now this is showing the Miller index, the Miller indices. Okay, now if you're drawing, if you want to draw this plane, obviously you have whatever that I've showed you earlier. Yeah, this is bad, but I hope you understand. Okay, then now if this is 1, this is 1, this is 1, for example, you can do something like this. This will be your plane. Okay, now see, because this plane it intercept the x-axis at this point 1, this point 1, y-axis at this one, and then this is the plane. Basically that's how you'll be able to draw this plane. That's why I even shaded the triangular region to visualize this plane. Do you understand? Okay, let's check if you do you understand up to so far. Okay, now the key takeaways will be the direction 1111 is a vector from 0, because you're moving from 0, which is the origin, to and then to 1. You are moving from 0 to 1. Okay, along the x-axis, y-axis, and the z-axis. And the plane now will intercept all these axes at so 1, it shows where you are intercepting the x-axis at 1, but now these ones, there's no intersection along the x-axis. Okay, and but now the second this number the second one, it means you are intersecting the y-axis, and then the third one, it means you are intersecting the z-axis. But now we now understand what a plane is. We now understand what the direction is. Now, what is this Miller indices? Miller indices are basically the notation system which denotes the family of lattice planes for a given Bravais lattice. So the orientation of a surface or crystal plane may be defined by considering how the plane intersect the main crystallographic axis, which is the x, y, z. These are the crystallographic axes. Now to determine the Miller indices, you have to have the plane. Now that plane, it will be intersecting this crystallographic axis. Then now when you must be able to determine those intercepts and then take the reciprocals. Okay. Now, how do you basically calculate this Miller, or how do you determine the Miller indices? You choose your frame of reference, which will be 0, okay? Then you locate your x, y, z, okay? And then axis intercept for the crystal face. For whatever the plane you are given, you are locating these x, y, z. Now we find the reciprocals of those intercepts. Now you enter the lattice constant for a given cell, then fill in the Miller indices in the form of the parentheses. Okay. Now, if the tip is, if you have, you must always have the Miller indices must always be in parentheses, and also it must be the whole number. Let's have some rules. You find the point where the plane intersect each axis. If the plane never intersect an axis because it is parallel, remember, the lines which are parallel, they will never meet. So if these things are parallel, it means the intersection point is infinity. That's what the point that I've raised initially. So you are putting the infinity. So the distance of the plane can be taken as 1 or half or 1/3, depending on the distance from the origin to the point where the plane intersect the orthogonal or the crystallographic axis. So the distance from the origin to the point where the plane intersect the axis can be taken as 1. But if the plane or if the intersection occurs halfway between the end point, the distance can be taken as a half. Okay, take the inverse of each intersection point. From then what do we know from mathematics? We know that 1 over the infinity is basically 0. These are just the rules. Now let's get into the real thing. You have got this, okay? You've got the orthogonal axis, you've got the x, you've got the y, you've got the z. So you've got the x, y, z. Okay, these are your orthogonal axes. What do you also have? You've got the plane. Okay, so what does the plane tell us? It tells us more about the intersection, the intercepts. Okay, the x, y, z intercepts. Now, can you now see that we've got the 0 as the plane of reference or the frame of reference? That is to say, now you've got you're intercepting the x at this point, y at this point, and there's no interception. Okay, there's no intersection here at the z-axis. Okay, now see that this z-axis, the z crystallographic axis, is parallel to this plane. It means the plane and this axis they will never meet. So it means for this one it must be 1 over the infinity, which is basically 0, because of the plane does not touch this z orthogonal axis. But these ones, the plane, this shaded pinkish thing, is touching x at this point and is touching y at this point. That is the first thing you are determining. You are determining the intercepts. Okay. So, what is the first step? You take 0 as the frame of frame of reference. Now you check as to whether the given plane intersect the orthogonal axis, okay, or not. So if they intersect at the apex of the cube, put 1. But if they intersect halfway, you'd put half. Okay, sorry about this. You can't put 0, but you put half. But if they never intersect, it means they're parallel to one another. You put the infinity, which 1 over the infinity is basically 0. Okay. So by looking at that plane, you have seen we have got the intersection in 1 and the infinity. So it can be noted that the pinkish plane intersects the x-axis at the distance 1. So so if you were to take the reciprocals of these things, you will say 1 over 1, 1 over 1, and 1 over the infinity. 1 over the infinity is basically 0. 1 over 1 is just 1. 1 over 1 is just 1. Now you put this thing in parentheses. So if it means if you are given a certain plane, you'll be able to determine the Miller indices. Are you following? Do you follow? You can type yes or no. Okay, that's good. Thank you for that. Now, the other thing that we see this plane. We see this plane. We see this plane. But now what do we notice is this is the frame of reference is 0. So we can see that this from here to there is basically twice what we see here from 0 to A3 and then 0 to A1. That's why we're saying the first thing is you take 0 as the origin. We have already done that. Okay. Check as to whether the given plane intersect A1, A2, A3. Clearly, the plane intersect the axis, but at different distances. The intersection of the plane with the A2 is twice the distance. Can you see A1 and A3? So that's why we're saying A1 A1, if it's twice, if A2 is twice A1 and A3, it means A1 is 1. Then it means A2 is twice A1 and A2, remember? Then A3, it will also be 1 because A2 is twice these things. Okay, now if you're going to be taking the reciprocals, it will be 1 over 1, it will be 1 over 2, it will be 1 over 1, which is basically 1, and then half, and then 1. But remember, I always tell you that we need the whole numbers. So would you be able to remove this fraction? Okay, to remove these 2, it means you must multiply by 2. So if you were to multiply by 2, it means 2 times 1, it will be 2. 2 times 2, it will cancel these 2. You are remaining with the again. It's like, okay, it's like you are saying 2 divide 2 will cancel this one. You are remaining with this one. That's why we put 1 here. And then 2 times 1, it will be 2. Now you put the parentheses. Now this, it will be your Miller indices for the Miller index for this given plane. Okay. Yeah, so these things are very interesting. These things are very interesting. Let's deal with this example 3. The example 3, I'm gonna just choose let's choose at least 2 planes for practice purposes. Let's choose this one. Let's choose this plane. Let's choose this plane. Remember, we've got the orthogonal axis A, B, C in this case. But now, you must always know that if you are having the B, positive A and negative B, right? I always tell people that A is approaching you. A is approaching you, right? So A is approaching you, remember. So this will be positive A, and then the back side it will be negative A. Then B is from the right towards the left. So it's from the right towards the, if you are taking you as frame of reference, A is always, okay, then this will be positive, then the backside will be your negative, then B, it will be from this way, then this will be positive, this will be negative, and C is like that. So you can use yourself as a frame of reference. Now I want you now to consider these directions, okay? Because negatives, they will tell us more about what's really happening, what is really happening. So let's I've shaded them the area. All right, so let's check. We always start with A. Let's see, we have got this plane. Does this plane intersect A? Yes, it intersects here at this corner, so we put 1. Do we have intersection at for B? Yes, here. But no, this is not positive B. This is, remember, this is the 0 with the frame of reference. This is 1. This is positive 1. But now the other side, it's 1, but negative 1. It's basically negative 1. So you will say 1, but because of is the other side, you are putting negative at the top. Now because remember there's intersection, then this plane also intersect the C, but at the positive 1, then you're fine. So even if you were to take the reciprocals, it will just be 1 over 1. Okay. Okay, then now you'll have 1 this and that. That's why this plane we're saying it's 1 bar, okay, and then 1 this plane. We can give you another plane. Let's use which one? The front one. Let's use this one. Let's use this one. So, do we have intersection at A? Yes, positive A, we are fine with that. Intersection, remember, we are following those rules for determining the Miller index. The first step is taking zero frame of reference, and then also you are having the intercepts. Then now it's 1, and then do we have B here? Yes, and then it's positive, so the intercept, so it's like X is 1, is like Y is also 1. Then do we have intercept here? C, yes, it means Z is also 1. You are taking the reciprocals, 1 over 1, 1 over 1, 1 over 1, which is basically 1, 1. Oh, sorry about that. Aha. Okay, which is basically 1 1 1 1 1, and then you close. Now this is your Miller index. Now that's why this plane is this one 1 1 1 1. Okay, so that's basically how you determine the Miller index. You should just follow the rules that I've just mentioned, so you can determine the rest to show if you really understand. Okay. Now let's use this last example. You're having this. Now they've given you the values. You've got 1 1 1, and then let's see, we have got the orthogonal axis X, Y, and Z. Now, what is the first step? The first step is to determine the is, do we have a plane? Yes, I see it, the shaded area. Okay. Now, do we intercept? Do we have x-intercept? Yes, x-intercept is 1. Do we have got y-intercept? Yes, here y-intercept is 1. Do we have got z-intercept? Yes, z-intercept is 1. Now, what is the second step? We are taking the reciprocals. The reciprocal 1 over 1 is basically 1. 1 over 1 is just 1. 1 over 1 is just 1. This is like that. Okay. Now, we have got this plane. We've got this plane. Clearly, we see that this plane, it intersects. We only have got x-intercept. Yes, but do we have got y-intercept? No, because this plane does not intercept and intercept the y-axis. So they are both parallel. You can see this plane and the y-axis, they are parallel. They will never meet. So you write the infinity. Now the z, do they intercept? No, no, they are parallel to one another. You write the infinity. Now we take the reciprocals, 1 over 1, 1 over the infinity, 1 over the infinity. And what did we say? 1 over the infinity is basically 0. 1 over 1 is just 1. 1 over the infinity is 0. 1 over the infinity is 0. And then put these things in parentheses. Now this is your Miller index for this plane. So I hope you can also follow what's basically happening here. But now, for this one, we have got this one, and then it means from here, from this 0 to somewhere here, it's 1. Okay, it's also 1. So now, and then also from here to there is 1. So this is halfway. The distance from here to there, they are equal. So that's why here it's 1. That's why here it's 1/3. Then now you're just taking the reciprocals. Now after taking the reciprocals, and then you'll agree with me that you'll get now this 1 2 3. Do you understand up to so far? Okay. Let me see. All right. Now that's good. Then now this marks the end of our lesson into the Miller index. You must understand this the step by step on how do we determine this Miller index. You must understand if you are given a plane, okay, how will you find the intercepts? Now, if you are given now the direction, how will you be able to draw the plane, and also how, yes, basically how will you be able to draw the plane? So remember, the plane is just basically, the plane is just basically the surface, and then this is represented by these parentheses, okay? And then now the square brackets is basically give us the direction. So from the direction,